Well, now I'm going to discuss about the Kubernetes, how to use it. Previously we used to do the Docker things, everything inside the EC2 machine, but it is not possible when you're doing it with the Kubernetes. Why? Because AWS provides us a free tier where we can able to explore a lot of things, but not the Kubernetes. As I previously discussed, when you're dealing with the Kubernetes, it is actually a container orchestration platform. Means a single container is managing multiple containers. Now, when you have only single container, the weight of that particular container is around 50 GB. Let's consider 50 GB. Now you are managing 5 to 10 containers. Now the weight of the machine become 500 GB. A single virtual machine, what we get for free tier inside the AWS is not sufficient to do those all things. For that reason, there are smaller version of the Kubernetes what you can use for learning purpose or the development purpose. For the production one, there are a lot of things. You have the OpenShift from the Red Hat. You have EKS, the Elastic Kubernetes Search from the AWS, and you have the GKS from the Google, and you have a lot of things what you can able to explore for the production one. For the development one, you can use a micro kit Kubernetes, and you can use the K3s, and you can able to use the Minikube for these all things. These are available in the Kubernetes uh, open source GitHub repository. And as of now, we will discuss how we can able to use those all things. As I previously discussed, kubectl is the one that is making request to the control plane has a API server that is connected with a scheduler, controller manager, etc, and API server is connected to the child nodes, or what we can call as a data plane. And the API server is making a call with kubelet. Kubelet is connected to kube proxy, and it has a container runtime, and inside the container runtime we have the pod, and inside the pod we have the container. It is not complicated, as I previously discussed these all things. Now I will show you how to go for these all things. This is a kubectl what I previously discussed. Now I am checking the version. Kubectl version, we got everything. Now I want to check the Docker version. This is the Docker version. Okay, we got a lot of things. I just want the information about the Docker version. As you can have a look over here, this is the Docker version. Just click on it, you will get the Docker version, build version, Ubuntu, it's all things. And I just clear these all things. Now what exactly I want to just check the nodes that are currently running, get nodes. As I previously discussed, a Kubernetes has kubectl, control plane, and data plane. We have the control plane. Let's check about the data plane. When I get say kubectl get nodes, it will give me a control plane and a data plane, that is a node 01 that is currently running. Inside the node 01, like we are going to create multiple ports. We are creating a multiple data plane over here. Now if I say kubectl, uh, we have to create a pod. To create a pod, there is something called as a YAML file, yet another markup language. We use that file to create a pod. Therefore, what I do, vim dot YAML. I go to vim, and over here, what I do, I just copy this particular thing. Many of developers, also DevOps engineer does this thing. What they do, they just copy the YAML manifest for creating a pod, and they paste it over here, and okay, paste it over here, escape, and we have to save and exit. Here the API version is given, and we have the kind, means there are different type of things that are present in the Kubernetes. For example, you have the pod, you have the deploy, you have service, you have the ingress, you have the reback, you have a lot of things. As of now, we are creating a pod, therefore kind is pod, metadata and name. Name, label, selector, that are essential. I will discuss these all things in the services video. And we have the specification that we are creating a container with a name Nginx, and the image is Nginx 1.14.2. I previously discussed about the container images. We have the pods where container port is running in the 80 port. Now our nginx is actually running over there. I save and exit from this particular thing. Now if I use a kubectl create -f using a file pod.ml, if I use this thing, my nginx pod is created. As you can have a look over here, pod/nginx is created. Now if I use it nodes here, inside the node 01 my pod is actually running. And if I want to get the pods that are running, I can just say get pods, kubectl get pods. As you can have a look over here, my nginx server is actually running, and the ready state is /1/1. See, there are there are some additional things that are missed out over here. I can mention -o/void. It's gonna give me everything. The status that is running, ready state is 1/1. There are two additional things like the current state and the desired state. Current state means currently how many pods are running. Desired state means how many pods have to run. If the desired state is 5/5 and you're currently under 3/5, then your ready state will be 0. The time when your current state become the ready state, at that mode of time everything become possible. We have the IP address, and if you want to get all the pods that are currently running, uh, uh, without it just give us static information. If I use -o void, it gave me static information. If I want dynamic, the current state, then you can use get pods -w. Now it is showing me the current state of running. Now I will create a new tab, and I will show you how these things are actually working. If I delete it, how it is getting terminated. Now here I use kubectl delete pod pods nginx. The pod nginx is deleted. Now see, as you can have a look over here, this is running. After that it is getting terminating, and it is completed. This is how it actually got started. And if I just ask about the pods, it will show you no resources found, because we have successfully created and deleted them. This is the first thing. And this is how we go with the pods nodes, and creating a pod, deleting the pod. And now I will go with some another thing. We are having the deploy. Pods has to be running. Pods always has to be running. Previously we have discussed about the pods, we have discussed about containers, but we discussed about the deploy but haven't explored it. I will show you how we can able to create a deploy. What actually happens with the deploy? Deploy has two things: auto scaling and auto healing. When you are using auto scaling and auto healing, uh, auto healing means if a pod goes down, then Kubernetes itself, it brings it back using a Kubernetes deploy. And auto scaling means if for a pod there are 100 visitors that are visiting that particular pod, and eventually you created a 4 pods where 400 users are reaching out to those pods, and eventually if your traffic become 500, then a new pod has to be created. This is done using the deploy. First of all, I will show you how it actually goes. Previously I had discussed about the pods. Now I will show you, there is another thing called a deploy. You just need to go over there, Kubernetes deploy. Once you go over there, you have the Kubernetes deployment, and you come over here. They have given everything like the API version. You have the kind, as I previously discussed. The kind is a type of thing what you're doing. Metadata, it has given me the name, and it has given me the labels, that is app nginx. Specification, I want to create a 3 replicas. This is the selector, and this is a match label, everything. Okay, I will come over here. I create a new file, vim deploy.ml, and over here I just insert the same file what I got from there. I escape save, and as you can have a look over here, this is the selector, and this is a match label, that is app nginx. Just keep an eye on the label and the selectors, that's all. nothing complicated over here. Once you do that, what you need to do, you need to create kubectl, the same command, create minus f. You have to use deploy.ml. Okay, here a deployment is created. If I say I want all the pods, see there are three pods that are currently running in this particular thing, the nginx1, nginx2, nginx3, but the second one is not running as of now. It might take some time, it might take around 15 seconds to create pod that is running currently. And as you can have a look over here, it has successfully created. All the states are ready, we are good to go now. Now I will show you another thing, kubectl get deploy. It will give me the number of deployments what we have done. As of now we have used only one deploy to do these all things. And as you can have a look over here, the one deployment is nginx deployment. Now I want the replica set. What exactly is a replica set? Previously, what used to happen in the deploy, there is something called as the replica set. The replica set is a one that is actually performing these all things. The replica set is reading out the YAML manifest of the deploy. It is reading out every replica that has to be created, the container that has to be running. It is going through those all things. And the time when some pod get deleted or there is some changes for the pod happens in the deploy, the replica set directly goes to the YAML manifest of the deploy. It will read, okay, 4 pods must be created. Are there any 4 pods? No, there are no four pods. I will create it. And there is some pod gets deleted, like there are 4 pods, one pod get deleted, and it will go through those things and it will check, okay, there must be 4 pods that has to be running, but there are 3. I will create a new one. Before the pod gets down or it is getting deleted, parallelly it will create a new one. The replica set parallelly create a new one. I will show you. As you can have a look over here, I will just show you kubectl get pods, and in the current state, currently running, how many are currently running. In the tab 2, I will show you. See, over here in the tab 1, this is the name of the nginx server. This is the name of the nginx server. I will just copy this particular thing, and in the tab 2 I will come over here. What I do, I use kubectl delete pod, and I will paste this thing over here. When I say the pod it is getting deleted, as you can have a look over here, this is the first pod, this is the second one, this is the third one that are actually running. And which one we have deleted? We have deleted 4sgj8. 4sgj8, it is getting terminating, and a new pod it is getting created parallelly. And before that, as you can have a look over here, 9z9xx, it is pending, and it is container creating, and it is getting terminating, and it is completed, and it is actually started creating, and it is running. Means you are going to have a zero downtime for this particular thing, because eventually when your pod it is getting deleted or it has having some issues, and it has some resource issues, and it is getting down, parallelly a new pod is getting created because of the replica set. It is continuously monitoring the pods, it is continuously reading the YAML manifest of the deploy, and it is doing these all things. Therefore in the deploy, we got the replica set, we got the pods, and we deleted the pods. It eventually created a new pod, and we did these all things. Now I will just cancel this thing, and I will clear these all things, and kubectl get deploy, kubectl delete okay, it's getting deleted. I have successfully deleted the deploy, and this is how we go with it. No resources found. And this is all about the deploy and replica set. Replica set is also getting deleted because it comes up with this thing. It comes up, sorry, it comes up with the deploy itself. When the deploy is created, automatically the replica set is also created, because the replica set is one, it is brain of a deploy. It is continuously reading and it is continuously monitoring. This is the one what we are discussing. And I will just create a new thing. I will just go with Nginx one.